In section 3 of chapter 4, we're going to again be finding the x-intercepts. This time, we're going to kind of circumnavigate factoring again, and we're going to be utilizing square roots. This is an algebraic process. It only works in specific circumstances, so it's not a tool you can always use. However, when you can use it, it makes the math really, really easy. But before I hop into it, I want to remind you of a few things. If I asked you to solve all 5 of these problems, the process would be rather straightforward. I expect all of you to know how to do all of them, but I want to really hone in on something specific. Problem number 1, if I wanted to solve for x, I need to get rid of the plus 3. We get rid of adding 3 by subtracting 3, because adding 3 and subtracting 3 are inverse operations, so they undo one another. And you get x is equal to 2 for that problem. Number 2, I have the subtraction of 4. If I want to undo that, I've got to add 4, because subtracting 4 and adding 4 are inverse operations, and inverse operations undo one another. And I would get x equals 3. For number 3, I have 2 times x is equal to 8. If I want to get the x by itself, I got to get rid of the 2 by dividing. The reason I divide by 2 is because multiplication and division are inverses. They undo each other. And you get x is equal to 4. No big deal. Fourth one, we have x divided by 7 is equal to negative 2. I would multiply both sides by 7. The reason I multiply both sides by 7 is because division of 7 and multiplication of 7 are inverses, and they undo each other. Hopefully at this point I'm sounding like a broken record, because I'm about to actually break that record. Number 5, I have the square root of x is equal to 5. The way I get rid of square rooting is doing its inverse operation, which is squaring. That's why we call that a square root, and a second power a square, because those are inverse operations. And what do inverse operations do? They eliminate each other, and you get x is equal to 25. Everything on here should not be a shocker. It's no big deal. It's no big surprise. However, there is something that kind of breaks the mold. If I give you x squared equals 25, the way we go about doing this problem is a little bit different. And you need to be careful, because the mistake that you'll end up making is purely because you're stuck in the rhythm so much of, I'm just going to do the inverse operation, they'll cancel, and I'm done. So if I want to solve for x, I'm going to square root both sides, because a square root and a square undo each other, and x is equal to 5. We all good with that?
No.
Yeah?
No.
You shouldn't be, because I did it wrong. The reason this is wrong, and this is only true for this mathematical operation, this is what makes it different than all the others, is yes, I do have to square root both sides to get rid of the second power. However, in order to get rid of an even power, you must recognize that there are 2 numbers that multiply to give me 25. 5 is one of them, but so is negative 5. So what we have to do is whenever we eliminate an even power with a radical, you must put a plus or minus out in front of it, because that plus or minus represents that there's going to be a positive and a negative version of this answer. Which kind of makes sense if you think about it in the context of quadratics, what we've been dealing with. Quadratics are parabolas. We're trying to find where it hits the x-axis. Parabolas can have 2 solutions. I now have a quadratic. It makes sense that I got 2 solutions. This is the process that we're going to employ in our problem solving today. But before I do that, I want to attach one more topic to this that is more of a foreshadowing of what we're eventually going to do. It is not what we're going to be investigating currently. We'll push this off till later in the year. But here's another problem I have. X squared equals negative 9. I would square root both sides. Now I remember, I need to put a plus or minus. I will guarantee you at least probably every single one of you will forget the plus or minus at some point, and that's okay. As long as when I say, what did you forget? You remember, oh, forgot the plus or minus. These will eliminate. What's the square root of negative 9? You can't square root a negative at this juncture. We will expand upon that later in the year. But for right now, what I do not want is I do not want you to say no solution, because that is technically wrong. If you want to be technical, which we're in honors, we should do this, it is no real solution. Because it does have solutions, they are just not in what we would call the real space. So now that we've gotten that aside, where if you're square rooting a negative, you just say no real solutions. Now I'm going to show you how we do these algebraically. Problem number 1. If I have x squared minus 36 equals 0, what we used to do, and you can still do this, is recognize, oh, that's a difference of squares. I can just turn that into x plus 6 times x minus 6 equals 0. Set each one equal to 0, x plus 6 equals 0, or x minus 6 is equal to 0. You'd solve each one of those. So for the first one, I'd subtract 6 from both sides and get x equals negative 6. The second one, I would add 6 to both sides and get x is equal to positive 6. These are my solutions. Nothing is wrong with that process. That was solving by using factoring. That's fine. That is perfectly correct. There's nothing wrong with that. However, there's a faster way of doing it simply by using algebra. The other way I could do it is if I have the x squared minus 36 equals 0, if I add the 36 to the other side, you'll get x squared equals 36. If you just square root both sides, don't forget your plus or minus, we would get x is equal to plus or minus 6, and we're done. Same answers, different approach. I still got my two answers of 6 and negative 6, except this method was more algebraic and less factoring, which is still an algebraic process, but all the same. This is what we're doing. I'm trying to get you to use the algebraic process. Even if you're comfortable with the difference of squares factoring technique, I want you to use this new technique with square roots because I want you to get into the habit of remembering to utilize plus and minus symbols. Because eventually we'll get to problems where you're going to have to use the square root technique and you can't use the factoring technique. And if you forget the plus or minus there, it can really throw things off. Problem number 2. If I want to solve for x, I'm going to divide both sides by, add 12 to both sides. Let's get rid of the subtraction first. That'll give me 3x squared is equal to 12. Divide both sides by 3. X squared is equal to 4. Square root both sides. Don't forget the plus or minus. And that'll give us the answer of x is equal to plus or minus the square root of 4 is 2. And we are done. Problem number 3 is the first one that's unique because there's a y in it. Remember, we're trying to solve these things. We're trying to find where these parabolas, where these quadratics hit the x-axis. On the x-axis, all coordinates have one thing in common. The y value is always 0. So you can just get rid of it. 0 minus x squared is just negative x squared equals 81. Multiply both sides by negative 1 to get rid of the negative in front of the x squared. We'll have x squared is equal to negative 81. You might begin to see why this is going to be an issue in a second. Because if I square root both sides and put a plus or minus, I'll get x equals the plus or minus the square root of negative 81, which means no real solutions. Again, just to reiterate, you have to say those words. You cannot say no solutions. You cannot say NA. You have to say no real solutions. Just to nitpick a little bit more, technically you have to say no real solutions. You can't say no real solution singular. there are still going to be two solutions. They're just not real. So technically, if I want to be super technical, there has to be an S at the end of the word solutions. Lastly, problem 4. The y value is 0, so you can kind of just imagine it doesn't even exist in the problem. Subtract the 7 from both sides. You will get negative x squared is equal to 5. Sorry, not 5. 7 minus 7 is 0, Mr. Silva. Multiply both sides by a negative 1 to get rid of the negative in front of the x squared. And we'll be left with x squared equals 0 times negative 1 is 0. Square root both sides. Put a plus or minus. The square root of 0 is 0. Plus or minus 0 is still 0. So x equals 0. This is the one and only case where you're going to have a quadratic solving using the square root algebraic method where you're only going to get one number. It's when the solution is 0.